We are very happy to have Professor David Li to guest lecture here. He's going to tell us something about AI for social good, or like collaborations between human and AI. David is a professor at computational media, and he came here a couple years before me. It was truly impressive. I know David's work several years ago, and even at that time, AI was not super hyped. David was thinking about this like AI-human collaboration, like how human and AI can interact. So that was pretty remarkable because not so many people were thinking about this. Now these days this is popular, like everybody jumped on this topic easily, but at that time it was not an easy thing to do. David graduated from multiple very good schools. Okay, I'll let David introduce himself. Do you want to introduce yourself?
Sure, yeah, thank you. Yeah, thank you so much for having me. I'm really excited to be here. And yeah, I know Yang from way back.
We are not that old.
We're not that old, yeah, I know. But yeah, so I'm going to be talking today about HCI and AI for society. And basically, you can tell this is a very focused talk because it just kind of goes all over the place. And I'm going to try to kind of tie it together. And I just basically threw all the stuff I'm interested in, and hopefully it will be interesting to you. Let's see. Okay, so this is John C. Brown, and he describes these three different eras for how we live, work, and learn. He says that when he was growing up, his father was advising him on his career, and he said, "Hey, John, think of yourself as a steamship. Right? Set a goal for yourself, and just like go for it. Don't let anything get in your way." And John said, well, when he was actually building his career, which was very successful, he said that his career was more like a sailboat. It was more, instead of powering through obstacles, it was more getting a sense of the different winds of change and tacking along to get to the place he wanted to be. And he says that now we're in a whitewater world. So you're not just tacking around to get where you want to be, but you're constantly being buffeted by new rapids, and you have to adjust to even stay afloat. So what's the reason for this whitewater world we're in? Well, if you think about the digital infrastructure that's changed in the last couple of years, there's been a lot of changes. You obviously have the internet, which connects us to information, connects us to each other. It's created this digital world that we can tap into. But you also have our devices, right? So the things that our smartphones, the Internet of Things, the things that take our digital world and kind of plug it into our social and physical worlds that we're connected to, so that it's not just us kind of logging into this digital world, it's actually it sending push notification to us. And then you have the cloud, you have the API economy, and all this infrastructure that makes it really easy to develop, deploy, and scale new technologies, and then bring them into this digital infrastructure that then affects our social and physical worlds that we're living in. So what does that mean? It means that we have this connected digital, social, physical world, and that there's these new technological innovations being introduced in it that are not just affecting our digital world, but also how we live and work, right? And we have to figure out how to adjust to it, how we live in such a world. So my research is in social computing. That means I study the intersection of computational systems like these and social interaction. And in social computing, we like to study what we call socio-technical systems. So they used to be, isolated systems, think Facebook or Twitter, they're in the cloud, and we call them socio-technical systems to remind engineers that they're not just technical systems. They need to be designed for the people in it. And the properties of that system also depend on the different social dynamics, the social norms, and the human factors. Well, I think we're in this place where we're not just dealing with these individual isolated systems. This connection between this global digital world and our social one has created a socio-technical world that we're living in. I like the way that my past PhD advisor put it. Ashish Goel, he's from Stanford, and he said, algorithms used to be what made computers run faster. Now, they're creating social and economic systems. And they're creating political systems and educational systems. Does anyone relate to this? So, what does it look like to live in a whitewater world? Well, our economic system is kind of organized around expertise and professionalization, right? You go to school, study for many years, you come out with some area of expertise, and you enter the economy and contribute to society, right? That's kind of how it's supposed to work. At least that's how it's supposed to work in a steamship or a sailboat kind of world. But when you're in an environment of constant change, that changes the way you learn. You have to continuously learn, and you have to learn in new ways that kind of cross knowledge boundaries. But it's not just learners that need to be adapting. Our educational systems, they also need to provide ways for students to keep up with that pace of change. And our work institutions need to support on-the-job learning. So there's all these different things that we need to do to adapt to a changing world. And it's not just individuals, but it's also the communities that need to do this adaptation, right? So people are, asking the government, asking nonprofits, how are we going to regulate and create new policies for all the new change that's happening in our world? When you have to deal with driverless cars, blockchain technology, right? All of these things have impact. And how are we providing services for the people who fall through the gaps? And these are all really challenging questions, but they're important for thinking about this socio-technical world that we're in. It's not just technological rapids. There's a lot of different rapids, right? Natural rapids, political rapids. We're in a whitewater world. It's hard to imagine how to live in it. So what I want to do in this talk is to explore this question of living in a whitewater world. And really, these are big questions. So it's really about exploration, not answering. Asking questions, doing a little bit of dreaming. And I'm going to be focusing around these three topics. So the first is, right, how do we support communities in navigating a whitewater world through large-scale societal collaboration? And then how do we help individuals navigate a whitewater world by thinking about how we can reinvent education for continuous learning? And then finally, how do we work towards human-AI collaboration that supports individuals and communities in navigating this whitewater world? Okay, so the first two are going to center around kind of past projects I've worked on. It's going to be, much more at a high level, paints the big picture of some of the things, my own journey through these topics. And then the last topic, we're going to go more in depth in talking about some work that I'm thinking about right now, and yeah, details around that. Cool. Okay, so let's start kind of roughly where I started at the beginning of my PhD. I was working on voting and decision making. One of the closest ideas to kind of this concept of large-scale collaboration is what's called participatory democracy. So this is an idea from political science that advocates greater involvement of people in political decision-making. So the idea is, if you involve more people, that can promote civic engagement, it can foster accountability, transparency, leadership, and then hopefully allow the government to tap into the knowledge and expertise that already lies within their community. And there's a lot of examples of this kind of thing already being done in real communities, in real political settings. So from local to national governments, one of the more successful widespread models of this is called participatory budgeting. And how it works is that a government sets aside some of its money, and it basically lets the community members decide how it gets spent. There's also examples around things like policy reform in Finland, crowdsourcing the off-road traffic law, and even on constitutional reform in the Icelandic experiment. So all sorts of different types of experiments around this topic. And roughly speaking, all of these experiments unfold through roughly 4 stages. Okay, so this is participatory budgeting in particular. After the process is designed, community members, they start by brainstorming ideas. These ideas are developed into proposals in partnership with different city agencies. They're voted on by the community, and then finally the top projects or policies are funded or implemented. Now the major challenge in these kind of processes is that they don't scale very easily. Everything requires kind of going in person to a town hall meeting that has a certain room size, and then there's a challenge of managing all the ideas, right? So if you have a large number of ideas, how does any person actually look through all the ideas, much less rank them or discuss them or talk about them? So those are kind of 2 of the challenges. And when we got involved in working on this, we mainly did 2 things. So first, we created a simple voting platform that helped to bring some of their processes online. And then the second thing we did is start thinking about algorithms for voting at scale. So if you have 1,000 ideas, no one has time to look through all of them, much less rank them. So how do you find the top ideas? And this is an area of research called preference elicitation. So basically, instead of asking a user to rank all 1,000 ideas, an algorithm, it might just pick 2 ideas and ask a participant, well, which of these ideas do you like better? And this is obviously a lot easier for the participant. But the question is, can this find the true output ranking, or something close to it, that would have resulted if everyone had given their full ranking? And hopefully, can it do it in a small number of comparisons per person? So I told you that the first part is high level, so the answer is yes. Okay, I'm not going to go into the details, but the short answer is in practice, yes. And you really only need a small number of comparisons. And there's like all sorts of theorems like this one that say, for different types of voting rules, essentially you need on the order of something like m log n comparisons, where m is the total number of proposals. That's great, because even if the number of proposals is as large as the number of people, that means you only need around log m comparisons per person, right? Which is good if it's log m. In practice, extrapolating from the work we did in Finland, if you have around like 1,000 proposals, 10,000 people, roughly this means, after you get the constants, around like 10 to 20 comparisons per person. So I thought that was really cool. Like, oh yeah, you can achieve some kind of large-scale collective outcome with just a little bit of contribution per person, right? So you're approximating what would have happened if everyone had ranked 1,000 proposals, which is completely impractical. Yeah.
How do you aggregate the ranking? How do you aggregate the pairwise comparisons to generate the ranking?
Yeah, so there's different ways to do it. In the case of this Borda thing, so one of the key things is just random sampling, but you can sample in different ways, and then there's a bandit version for kind of eliciting. And there's all sorts of other methods outside of what we used. I think, yeah, so things like minimizing max regret, that's something that Craig Butler did. So a lot of different types of techniques for this. And there's also a lot of different types of goals depending on the type of voting rule you're trying to achieve. Because there's not one function for how you go from a set of rankings to end ranking. I'm kind of glossing over all this. But so I thought it was really cool. And then I talked to Jonathan Reichenthal, who was the CIO of Palo Alto at that time. And he asked this question, well, how do you know that the top ideas are actually better? Right? Are the most voted for proposals really the right ones? And I had to admit that I didn't really think so, right? So this wasn't an election for representatives This is actual decision making. The level of participation we have here is not, even close to the level of participation in elections, which is already, not that great. So, I found it hard to argue to myself that, to the people who are actually thinking about the policies, that, the top ideas are necessarily the right ones.
But this is a terrible question. Counterfactually, you wouldn't know which one is better, right? You choose this one, you choose the top 10, but then you don't really see the rest of the proposals. Counterfactually. Yeah,
so I think what he's getting at is like he wants some way to aggregate ideas based on, real deliberation on the pros and cons of the different types of proposals, and maybe some evaluation of based on some normative properties of their impact on the community. So I think that's kind of what he's getting at, is like if you just have a ranking of and you're just saying these are the top ones, well, that's kind of like, well, I guess these are like old political questions, right? Like tyranny of majority, all sorts of things like that. But especially in the context of these participatory budgeting or participatory democracy kind of events, I felt like a lot of the arguments maybe for like representative democracy, well, it's like a little bit weaker because it's happening, if you're thinking about applying it to like all sorts of these different things, and most people don't have time to participate, does it really make sense to just aggregate votes? And this made me think, right, can we go beyond voting? Because the interesting part is not just the voting itself in participatory democracy, but actually the process of coming up with ideas, right? Or maybe it's the process of deliberating and learning, right? Because those are the parts where you're engaging people to like, get new information. And, that intuitively makes sense because people can do a lot more than just vote, right? They can talk with each other, they can make compromises, right? So how can you incorporate that type of contribution into these algorithms? What would it look like if there was like 1,000 people here kind of talking to each other, making compromising decisions? Well, that's also not practical, just like it's not practical for any person to look at 1,000 ideas. So I thought, what if, just like we used a sequence of comparisons to approximate a large-scale vote, could we use a sequence of small group deliberations to kind of approximate a large-scale deliberation, whatever that means? Okay, so that's kind of basically what I was thinking about. And what would it look like if I were to have an algorithm that said, hey, Yang and Yatong and what's your name? Saeed, right? Like, why don't the three of you like get together and talk to each other about what you think the right proposal is for XYZ problem? And you can do whatever you want, but at the end, you have to agree on something and then report that to the algorithm. Okay, you have to come up with some compromise decision and let me know. And then after you do that, then I'll pick another 3 people and I'll repeat the process. Okay, so what do you guys think the decision should be? And you can talk and whatever. And could we create something where you take a sequence of these things and you get to something interesting? I'm not going into the details, but it turns out that roughly speaking, you can. And what I mean by roughly speaking is, well, this is a mathematical model. So what does it even mean to do that mathematically? So how we modeled this is we said, suppose that people are represented by points in space. So kind of, I'm closer to people who have closer preferences to me. And suppose that every group of 3 people is able to converge to a good compromise decision. So what does good compromise decision mean? Let's say it's like the point that minimizes distances to each of you. And then we showed that if that's true, if groups of 3 are able to come to their compromise decision, then you can use a small number of these small group deliberations, so also n log n, to find the top compromise decisions across the whole population. In other words, the points that minimize sum of distances to all points. And so again, n log n is good because you have n people. So on average, that's log n small group conversations per person. So I thought, okay, that's great. That's really cool. But again, real deliberation is not just, let's get to the median opinion, right? That's just compromise. It should really capture changing opinions. So, you state a really interesting new piece of information, and I'm like, wow, that's an interesting way of thinking about it. I changed my opinion, right? That's kind of like what you'd want to see in participatory democracy, getting all the perspectives and aggregating that together towards some better outcome. Or how about ideation, like coming up with new ideas? So I thought that's what I really want to work on. But how do I work on that? Using mathematical models. And so I had done some work on opinion formation dynamics in the context of polarization, but I really struggled with how close are these models to thinking about ideation or deliberation or the things that I really wanted to work on. So that pushed me into this phase of soul searching, of basically, what am I doing with my life or my research? And is my research useful? How many of you guys are PhD students? Are any of you towards the end of your PhD? Okay, so if you're kind of getting towards the end, that's probably what you're feeling. Is I don't know what I'm doing with my research. It's completely useless. And so I started thinking about that and thinking, well, is academia really the right place to work on questions like these? And if not, then where? So I started doing all this, random exploration of different things. And see, the thing is, the research community that I was working in my PhD was really focused on mathematical modeling, right? Which was really great at understanding and designing collective properties, but not so great when I'm thinking about human factors or motivation or ideation or deliberation, things like that. And so I was like, okay, this doesn't make sense. And I thought, well, I'm at Stanford. I'm not going to go into academia, so I'm just going to explore entrepreneurship. That makes sense. And so I was working on some different startup ideas. I was very lucky to participate in some fellowship programs, took some courses in business school, and I really liked it because, well, there's, I had a really negative view of entrepreneurship before because it's it's all about just making money, people who want to control other people. Anyways, so one of the things I really enjoyed about exploring entrepreneurship is I realized that that's not really what it's about. It's really about how do you bring ideas from your head into the world and at scale and for impact. Well, there's also that other part. But so I started working on these ideas, still related, still in my mind, working towards the end goal of bringing communities together to work on problems. And as I was working on this, I started wrestling with this tension between monetization and the mission I really wanted to work on. And at some point, I just realized it wasn't gonna work. And at this time, Jeff Rakes, he was the ex-CEO of Gates Foundation. He came to talk to some students, and he said something really interesting. He was talking about his philosophy towards philanthropy, and he was saying, well, the private sector is great. He used to be an executive at Microsoft. And so he says, well, it's really great at providing services for things that are monetizable. And the government is also great. It doesn't have that monetization constraint. So it can provide services that don't have that, but it's not good at doing things that are high risk or require innovation. To have this gap in the middle, things that require a lot of risk and innovation, but maybe not clearly monetizable in the short term. And he was talking about, kind of philanthropy, but when he said that, it was like a light bulb came into my mind. I was like, oh, well, maybe academia could also play that role. Maybe, academia doesn't have monetization constraints. It's supposed to innovate and do high-risk things, right? Of course, academia has that publishing thing, right? Annoying publishing thing. So it needs to create new knowledge. And so I was thinking, okay, well, maybe this could work. Maybe I could, go back into academia. And I never officially left. My advisor is very nice, so just let me play around. And one thing I realized is that there's these different research communities, and each of them value different things. And they value different types of knowledge that are produced at different points in bringing an idea into the world. So I realized that there's actually people out there who work on human factors and motivation and design. That was HCI. So I started thinking, well, maybe I could go into academia and couple a process where I'm building things with communities and deploying them, while also kind of publishing across different communities. That was my idea. Everyone was like, that's a stupid idea. Don't do that. Wait till after tenure. So that's kind of the rough frame of mind that I had when I decided to jump back into academia. And now I was like, okay, I'm going to try to get into the design world and take a hold on the voting decision-making algorithm thing. And what I really want to work on is how to support people who are on the ground providing services, nonprofits, governments, volunteering. And right around this time was when the Syrian refugee crisis was erupting to over 4 million people displaced. And I was just struck by the scale of suffering. Like a third of a country displaced. Nobody wants to take them in. It's really a hard challenge. And my research was in crowdsourcing, but I didn't feel like anything I worked on was actually useful. So I started thinking about how can we organize people to do things, to support kind of volunteering and nonprofits. I wanted to start local, which is important for design, for iterating. And so I started thinking about refugee resettlement. The US at that time was the largest resettlement destination. Took around 70,000 to 100,000 refugees a year. And that process kind of goes through 8 different agencies. The largest is Catholic Charities, around 80% of that. And then there's also IRC, Jewish Family Services. So I started talking to them, wanted to understand, are there any ways that maybe technology can help organize volunteers to help them more? That was my basic thought. And I thought that, well, in the digital world, we kind of have examples of this. And we have Wikipedia, a bunch of people creating an encyclopedia. We have things like Fold It. It's a game where people learn how to fold proteins. A lot of people like playing it for some reason. And the top players, they actually have made scientific discoveries. And then there's Duolingo, which is a language learning app. I think some of you might have used it before. But how it works is as you're learning a new language, you're actually helping to translate the web. So there's actually all these different examples of how in crowdsourcing, people have been thinking about how do you organize a large number of people to do something. And I thought maybe I could apply that to the volunteering setting. I initially wanted to start with something simple, but whenever I was talking to typically the volunteer coordinator, our conversation somehow would lead to things like building a web app for them that would kind of change the way they delivered some certain service. And that's a hard problem for them because it's hard for nonprofits to develop internal expertise. They can't compete with Google and Facebook in terms of salary. And it's actually pretty hard to also cultivate a volunteer community around things that are complex and interdependent. Right? It's easier to do like packing boxes, sorting clothes, things like that, things that don't require expertise. So this is really a challenge that relates to complex crowd work. Right? How do you coordinate short-term volunteers around complex interdependent projects? It's hard because volunteers typically don't have that much time. They typically don't have that much experience. And so our thought was, well, what if we created a platform that teaches people how to code? Another one. But as they learn, they're actually automatically contributing to building real projects for nonprofits. So again, I'm not going into the details right now, but the short story is that it didn't work many times, and then it worked, kind of. And the first couple of times, basically, we found there's a lot of interest. People were excited, but it didn't work for many reasons. First, even when people said they were experienced, well, they were experienced in different ways of building websites. There's different stacks, there's different languages, right? Different best practices. And if they're going to be building a common website, well, everyone kind of needs to learn the pieces that they don't know. And so everyone is pretty much a novice. And so we tried having these like really detailed workflows that described exactly how it's supposed to work. And that was way too overwhelming and convoluted. And finally, we got to work for a simple case. So we just started by focusing on creating the view of a web app, so just HTML and CSS, given some design. And we recruited participants who didn't really have a prior background in HTML and CSS. So it kind of worked, right? People were able to take a design and build at least the view. But one of the interesting things that struck me in this process was how much students wanted to participate, even before we got it to work, right? We found that 85% of the participants said they wanted to join even if they were just recreating existing websites for the sake of learning. And it made me realize that students really want opportunities to learn skills in real-world settings. Oops, went backwards. And that's what got me to start thinking, not just about kind of volunteering, community governance, but also how that volunteering, participatory democracy stuff intersects with learning and work and experiential learning. A lot of knowledge is tacit knowledge. That means it can't be learned through lectures, right? You have to learn it experientially. And the way this used to happen is through apprenticeships, right, or internships. But internships need mentors, and mentors need time, right? So you probably have experienced before that getting your first internship is really hard, right? Because before you have that initial amount of experience, no one really wants to, not that they don't want to, but they can't really spend all that time with you if, in the end, there's not going to be some result or at least some contribution, right? So it's this vicious cycle where you can't get experience until you have experience. I think that's going to be a really important question in the world of AI and automation. Heather McGowan puts it this way. She says, in the past, we learned in order to work. That's the steamboat model, right? Now we must work to continuously learn. So how do we do this? Is it possible to scale opportunities for apprenticeship learning? Let's go back to how this worked in our nonprofit volunteering project. So how it worked is, like I said, we built another website for teaching people how to code. But instead of going through topical learning modules, usually most of these websites you learn HTML, then you learn CSS, then you learn JavaScript, right? And you learn all the different techniques. How it works in our case is you work through micro roles. So what are micro roles? Well, at the beginning, you might be an elements developer. So you have no background, and you're given the design for a small component, and you learn to identify the elements in that component, to declare them using HTML, and to style them using CSS, but not the layout, just the individual elements. And so you have this elements developer role, and you have these series of steps. Maybe you start with a conceptual step, and then you have these action steps where you are doing some work, but it's actually doing real-world work as opposed to some practice exercise. And then after you finish the elements developer role, then you move on to being a layout developer. And you're given the output of an elements developer. And now you're learning how to structure elements into a hierarchy in the DOM. You're learning to lay them out using CSS and position them relative to each other. And again, you have some conceptual steps. You have some action steps. You might have loops or branches, right? So basically, you have some workflow for doing your role. And again, it's working on some real goal. And then after that, in our simple case, you would move up to becoming a page manager. So this is someone who manages a page, right? They're in charge of decomposing the page into smaller components. They delegate them out to elements and layout developers, and then they kind of stitch it back together. And so each of these roles, they're small roles, take a couple of hours. And they're not just learning roles, right? Like I said, they're contributing to something. They're coming from this hierarchical structure, some opinionated hierarchy, that's kind of describing one way for how you might build a website, or in this case, create the view of a page. And the top role is kind of responsible for the overall goal, and they can delegate out pieces to other people. So it's a way of taking a process for getting things done and coupling it to some kind of experiential situated learning pathway, right? A pathway of micro roles where you can steadily work towards learning tacit knowledge. And you also have these nice mentorship properties, because as you work your way up the hierarchy, then you naturally mentor those below you because you have experience in those roles. A lot of times we talk about learning by doing, right? Learning by doing says that in order for people to really learn, we need to give them opportunities to do things, right? To learn in the context of real work. But is learning by doing scalable? So I think that maybe it's only scalable if doing by learning is possible. So what's doing by learning? I made that up. It's doing real-world complex goals by knitting together the output from learning by doing. Because if it's not possible to do that, then you're always going to run into this challenge of sustainability, mentorship costs. But if it is possible, then there's going to be incentives for people to provide opportunities for learning by doing. So I've been exploring this idea in other contexts. Collectively, it's another project in the lab that originally just started because I had a bunch of undergrads, and I was like, maybe they would like reading research papers, because of course everyone loves reading research papers. And it turns out that they actually enjoyed it. We started evolving it, growing it to people outside the lab. And the reason is if you pick the right papers and the right people, then it kind of gives students the opportunity to explore the creative side of computer science and to learn how ideas they're learning apply more broadly. They also get to build relationships with peers. You're splitting the work of reading, so it's a very low time commitment. And most of the groups that we've ran so far, they're exploratory groups, so it's kind of focused on building intuition, creativity. But we started to also think about and experiment with these small groups as building blocks for learning pathways, just like the micro roles are kind of building blocks for learning pathway. And you can have different types of these groups that introduce students to different parts of the research process, like ideation, literature search, and that also involves them in actually contributing. So one of the interesting things about this kind of building block is that it's in person, it's relational. It kind of goes back to like the early thing I was working on, like small groups, right? You can get richer dynamics. And it's one thing that's missing from the online world. And so there's other work that we're doing I'm not going to go into, kind of exploring what does it look like to build communities or organize collective behavior that's built on these building blocks of in-person relational interactions. Could this help with mediating polarizing discussions? Because it's impossible to have discussions about polarizing things online, right? So I've been kind of going all around and talking about some of my design work and really enjoying that. But I also like the mathematical side of the work that I used to work on. And so recently I've started thinking about, well, how do I revive my mathematical work and kind of bridge these together, which was the original goal. How do I add a stronger data component, blend it with design in a synergistic way? Well, I'm not going to go into this, but on the kind of one obvious immediate direction is to think about how we can model and augment different aspects of micro-role hierarchies and small group networks to kind of leverage the platforms we're building and the data sets that we have or are going to have. And right, how do we augment different forms of human interaction, like mentorship or management or group work and teamwork? The bigger theme that all of this falls into is trying to think about and work towards better human-AI collaboration. So what is human-AI collaboration? It's a recent hot word that people talk about a lot. One of the things people often are referring to when they talk about human-AI collaboration is they're talking about AI that is also having humans in the loop, right? So they say human in the loop, right? So you have an AI algorithm, and then they kind of bring in the humans when they need to, right? So oftentimes, this is related to humans labeling data, accomplishing other types of simple tasks that AI just isn't good at. Another way people think about human-AI collaboration might refer to things like smart devices, right? Things that, prosthetics that adapt intelligently to feedback provided by the user. Maybe they provide feedback to the user. So some kind of integration of AI and humans. One important question in thinking about human-AI collaboration is like, what kind of collaborative future are we working towards? Right? Are we working towards a future that's very, these are both human-AI collaboration. Are we working towards a future where it's very automation-centric, where humans are kind of low-cost labor? Or are we working towards a future where AI is augmenting and supporting kind of human work or human communities? I think
So
yeah.
What's the automation? What is the augmentation?
Actually, it doesn't fall cleanly like this. Like I kind of want to say like that, but it's not clean, because automation can really contribute to both sides. But sometimes I think that sometimes the automation view can be a little closer to that view, because it's kind of focused on automating away human, replacing humans, right? It's not that simplistic, because hopefully if you're automating away certain things, that's kind of helping humans to be able to do other things that are more interesting. But sometimes there's like kind of this, when people talk about it, sometimes they'll kind of map these together. So I think one useful way to think about these issues is to consider this axis of humans and AI interacting together and playing different roles that are either focused on working on a task or on coordinating multiple agents, whether they're AI or humans, towards a goal. So I would say that most human-in-the-loop work falls in this upper left quadrant, right? It's mainly like AI is orchestrating, right? And they're delegating simple tasks to humans to kind of work on, like label this image for me, thank you, right? Or transcribe this audio, right? But AI is kind of orchestrating. Or the smart devices example kind of falls in this bottom left quadrant, right? It's closer to a tool, right? That's particularly suited and responsive to an individual in carrying out a task. So what's here on the right side? Well, the bottom right is just what we've been doing all the time for ages, right? It's just humans coordinating, organizing themselves in organizations, and leveraging AI to do different tasks that are annoying. Like, in Excel spreadsheets, I want to get this linear regression or whatever, right? That's like some simple form of AI. But it could just be, any humans organizing themselves and then using AI in the course of our work, right? How about this top right quadrant? Something where you have both AI and humans kind of coordinating with one another and passing things on. And I don't think there's very many examples of this. And I think that one of the reasons there aren't many examples of this is that we don't have very good models of human coordination and collaboration, right? Because that's really complicated. Like, how do humans collaborate with one another? Well, I can't really model it mathematically. But since AI kind of ultimately relies on some models, this is kind of the class. I need to have some citations, like copy paste it. So since AI, it really relies on both of these three parts, right? There's modeling, there's learning, there's inference. So AI needs some underlying model, and if it's going to participate in or augment human collaboration, it needs some way of modeling that collaboration so it can kind of jump in and participate. So how do you do that? That's one of the things I've been thinking about. How do you model complex work? And how can we work towards a model of human computation that's more suitable for thinking about augmentation of human collaboration? But currently, our models of crowd work kind of look like this, right? They're really focused on this AI is orchestrating, and then humans are doing little tasks for them. It's really centered around human-in-the-loop crowdsourcing. And the focus of these models, if you are cynical, you're basically thinking about one of these questions. Right? You're thinking about, how do I manage those error-prone humans, and how do I do it without paying them too much? You're thinking about, how do you handle people who are lazy, who are strategic and manipulative, right? And then, hopefully, how do you get rid of them once you've used them and collected all that data and refined your model? That's kind of a cynical way of putting it. But that's kind of roughly what's happening. And it's not really the fault of the models or the researchers. It's just that we've been viewing human computation in a very silicon-based way. In silicon, you're focused on primitives that are fast, that are cheap, that are reliable, and then composing them together to get some computational goal, right? Hopefully, Turing complete, kind of thing. Here's an example of how we think about human computation from a very silicon-based point of view. Right? So here's a description of a challenge problem for something called a crowdsourcing compiler. So basically, this is a quote that's basically saying, okay, what is a crowdsourcing compiler? It's some kind of high-level programming language that compiles down to the primitive code that orchestrates machines and humans towards doing some tasks, right? So in the same way that today's Java programmers are relieved of low-level machine-specific decisions, the future crowdsourcing programmer would specify the goals of the system, leave many of the implementation details to the crowdsourcing compiler. And what they're basically trying to say is that, this is a challenge problem. It's a really hard problem. But they're saying, well, probably there's a way to get at this goal of creating a crowdsourcing compiler. Saying, well, we know that the organizational schemes in most successful crowdsourcing examples share a lot in common. The tasks to be performed are obviously parallelizable. And furthermore, the basic unit of human contribution required is extremely small. Fix some punctuation, label an image, etc. And furthermore, there's usually very little coordination required between the contributions. So it's saying, like, when we think about human computation, we should be thinking about very small human contributions with very little coordination between them. The presence of these commonalities is a source of optimism for the crowdsourcing compiler, right? It's basically painting this picture, right? See, silicon computation is about designing devices that are fast, cheap, and reliable for simple primitives. But humans are really sucky devices. We're not fast, we're not cheap, we're not reliable, right? So none of those things. However, even though humans aren't good devices, they're also not limited to small primitive tasks, which is what we're focused on in silicon. Humans are creative, they're collaborative, right? Humans can take some large, underdefined task, like take a man to the moon and back, right? A very underdefined task, and they could actually complete it, okay, maybe with some probability, maybe after a really long time. And so, the space of human executable tasks, or the primitives, is actually much larger. It's really wrong to think about them as these small primitive units. Given sufficient time and motivation, they can learn, innovate, plan their way to making it happen. Now, the outcomes that you want to be measuring, it's not just going to be error quality, right, which is typically what you're looking at human in the loop crowdsourcing, or cost. I guess cost still matters, but things like likelihood of success, like how long does it take, and maybe the more annoying thing is that creating a model for this depends on so many human factors, right? Like the ability to recruit a strong team, cast a vision, delegate work, design effective communication and learning structures, right? These are all parts of the pieces that determine whether someone is able to take an undefined task and actually accomplish it. So what would it look like to design a model of human computation that's not centered around composing simple computational primitives, but it's centered around decomposing, delegating, and coordinating underdefined complex goals? Yeah.
Sounds like coding.
Yeah, it is. It is kind of like that. Yeah. So how do you design a model of a company or organization or all the other things, the teams, market, or all those things that we use to organize humans to carry out work? Because we need a model of that to think about how AI can augment it. That's one way of thinking about it. So that's what I want to start working towards. A model of human computation that can reason about large, underdefined tasks, that can capture critical human factors, and that can explain some of the challenges that we see right now in complex crowd work. So let's take a stab at this. First, what we need is a big task. OK, there we go. We have a big task. And we need a worker, at least one. And we need to characterize these in some way, right? So the task has a size. The worker has some available time and maybe some expertise. Now, if it's just one worker, then there's not that much to talk about, because basically it boils down to, does this worker have enough time to complete the task, right? If they have higher expertise, they work faster. So maybe it's just expertise times time is greater than size of the task, right? That's pretty much all there is to talk about. For most of this talk, I'm going to assume baseline expertise, just E equals 1. So 1 unit of time accomplishes 1 unit of work. Just simplify that. So what happens if we want to think about many workers all contributing towards some big task? Well, we don't really have any structure in this task. It's just some big task, right? So for now, let's just think about these workers working sequentially on this task. So someone works on it, they hand it off, someone else works on it, etc. Well, intuitively, if the work is very independent, then basically they're able to complete the task if the sum of their available times is at least the size of the task, right? If it's very independent. But what if the work is very interdependent? This is where it gets tricky. How do we capture the challenge of interdependent work in a mathematical model? Let's start simple. So you have a task. Suppose you have a task. Someone works on it. They take 10 units of time to complete it. Let's say 10 days. Okay? Now suppose that you have the same task, and you have 2 homogeneous workers. Okay, so in other words, they have the same expertise. Like everything is equal about them in terms of their experience, expertise, whatever, as that original individual. So what happens if the first person stops halfway and passes the task to the second person? How long will this second person take? Is it also, 5 days have been spent so far, so is it 5 more days, right? Well, if you think about it, in your experience, it'll probably take longer, right? Think about if you're working on a research project and you finish half of it, and you pass it on to someone else with exactly the same experience, it's probably going to take them a lot longer because you've built out a bunch of context from working on the problem, right? A bunch of intuition, a bunch, all those sorts of things. The second person that comes in, they need time to pick up that context, right? And the time they need will depend on how interdependent this task is. So we're going to capture this intuition by giving tasks an interdependency parameter. So this parameter is just a number between 0 and 1. It captures the extent to which context can be passed from one person to another. So specifically, it describes the amount of extra time that someone would need to spend due to lost context. Maybe like reading the documentation or whatever it is, right? So if gamma work has been done so far, then a new worker that's starting at this point, they would need to spend gamma times d extra time to pick up the context. Yeah.
So the time, the kind of the task at different time, if it's like 1 unit time at t equals 0 versus like 1 unit time at t equals 10, they are equally difficult.
Sorry, say again?
Yeah.
Oh yeah, you're saying the expertise thing is same across this whole thing.
I'm thinking like maybe the later tasks they're like harder compared to the early ones.
That's a great point. Keep that thought. We're gonna handle that later. So if you go back to our original example, the second person, they would need to spend 5 times dv time to pick up context, and then an additional 5 units of time to complete the rest of the work. Okay? If d is 0, that's basically saying it's completely independent. There's no interdependency. If d is 1, this is saying that's impossible to pass on context. Basically, the second worker has to start from scratch, redo the work in order to build that intuition to kind of continue. So I would say, like a research is kind of like that. It's a really interdependent task. If someone leaves halfway, kind of have to start over mostly. At least it's close to 1. So this is essentially the model. In the full model, we have a task graph, a directed acyclic task graph, which allows you to represent the structureless units of work in relation to other units of work. Right? So for example, if you wanted to model different parts that have different expertise, you could use this. Right? So you can have like a sequence of pieces of work and have different expertise for these different nodes. And just like there is an interdependence parameter for a node, there's also interdependency parameters for each edge. And the edge ones are basically the same. They describe the context that an individual needs to pick up from task U before they can work on task V.
So this is like shortest path thing. You're going to find the shortest path between 2 nodes. Because what if there are multiple passes going from one node to another?
Yeah, so right now, the model of this task graph is actually this represents the entire goal, like take a man to the moon and back. Okay, so you have to complete the whole thing. In terms of, and then you assign people to different tasks to carry out. So I'm not sure what you mean by shortest path.
Like, say like 2 variables, they are not connected directly. So
yeah.
First of all, is the graph like fully connected?
It does not have to be fully connected.
Okay. So
if it's not connected, it means it's independent. So you can work on either of them without context cost.
Oh, I see. So even if we're both, say we are 2 tasks, we are both connected to J.
Yeah.
Still we are independent.
Yeah. So we depend on
Right. Like we're connected
tasks, right?
We are all tasks.
Okay. So J represents defining the specification or something, and mine is like executing one part and yours is executing that part, right? So we kind of only depend on him, right? So so we're independent of each other given that.
Okay.
Yeah.
It's like quite a restriction to doing the acyclic graph.
Yeah. So the reason why they are acyclic graphs is we're kind of thinking about it also as like the order that the work gets done. So like, you first have this task, and then this depends on this, and then like this follows this follows this, right? So you would only depend on the stuff before. Now, probably, what you might want to say is like, but the simplest non-acyclic graph would be like two nodes that are both dependent on each other, right? And you would say, okay, well, there's actually tasks that have that property, right? Both depend on each other, right? It's kind of what you're saying, right?
So maybe, you haven't done graphs in a while. If it's a directed acyclic graph, that doesn't necessarily imply the tree, right?
No, it doesn't imply it's a tree. Yeah,
Okay.
yeah. But I think you are getting at something which is like, for a lot of tasks we think of, they both have context to each other. But the way to think about it is like if those tasks are broken down to their like basic units, then it would be directed acyclic. And usually the tasks we're referring to are actually collections of tasks, right? Like I start with this, and then someone else does this. We depend on each other. So now we can, if we have this model, we can start asking questions like, how scalable is complex crowd work? That's a very abstract question. So how we formalize this is we say, is with this notion of work capacity. So what work capacity is this, okay, F is work capacity and it has these two parameters. This is the set of individuals. So in this case, we're saying n homogeneous workers. And this is a family of graphs. So this is just any set. And these are the set of graphs that have the same interdependence structure as G, but they have different sizes. So in other words, if you take that graph and you multiply the sizes by some constant C, for any C greater than 0, that describes a family of graphs that are different sizes but same interdependent structure. So you can ask, like, if you have an infinite number of workers with, let's say, for simplicity, we're saying they're homogeneous. Okay, so they have the same expertise and time. What is? Oh, sorry, I didn't define what F was. Okay, so F is the largest graph in this family that this set of workers can complete. Okay, that is feasible for this set of workers. So that's kind of like the capacity of that set of workers, right? And we can ask questions like, if you had an infinite number of workers, what's the capacity, right? I mean, hopefully it would be infinite, right? Like if infinite workers, of course, infinite work, right? Well, if you think about it, as long as the interdependency parameter D is non-zero, you can show that the work capacity, even for an infinite number of workers, is always bounded. So in this case, this is saying, okay, homogeneous workers, they have the same expertise for all subtasks in the task graph. It's just E, just to simplify things. Then the work capacity is just going to be expertise times time times this thing, which is basically the task granularity, divided by D. Okay, so this gamma G is just the relative size of the entire task graph to the largest subtask, or to the largest subtask plus its dependencies. Yeah?
Is T the total time that you allow all workers to work in union, or is it the
available time for one?
Okay.
Yeah. So it's basically depending on these four things, right? Interdependency, expertise, time, and task granularity. Nope, task granularity. And it's interesting to think about this in the light of the trends in HCI and the design community in trying to get towards more complex tasks, right? So, in the early days of crowdsourcing, it was just like parallelizable tasks. Everything was parallelizable. And then people started doing micro-task workflows. They're saying like, okay, and so it's always like have very small tasks for people and orchestrate them together using workflows to get at complex things. And essentially, and then after that, that started reaching a bottleneck where people were like, okay, these aren't able to solve harder things like building a website, right? And so people started to work on, say, okay, well, let's have workflows, but each unit is a large macro task. That's all it is, the same thing. And then, well, once we have macro tasks, then we start saying, okay, well, we can't use Turkers anymore. We have to use expert workers, like from freelance platforms. And that's kind of the trend. And you kind of see that reflected in this equation, right? So if you have these constraints, then basically what you need to do is either make the task granularity really small, which is what people are doing in microtest workflows, or make E and T large, right? Which is just get long-term expert workers. It's also interesting to kind of reflect on different things like this is a quote related to social mobilization. So given all we have learned about social mobilization, why isn't social media a more reliable channel for constructive social change? Social media has been much better at providing the fuel for unpredictable burst demobilization than at steady, thoughtful construction of sustainable social change. So basically, people are saying, hey, we've done all this work related to how to crowdsource things through social media, like open call, right, spread through Twitter, get a bunch of people to help on different things. And basically, well, the reason why we're not able to do steady, thoughtful construction of sustainable social change is because sustainable social change is a large, complex problem, a very interdependent problem. And when you're mobilizing people through social media, the vast majority of participants are short-term novices, right? So there's going to be a fundamental bottleneck. That theorem generalizes. If you vary the node expertise, so these are still homogeneous workers, but now they have different expertise for different subtasks. Then you get this equation. And so T is still the same T, the time that people have. SG is just the total size of the task graph, right? So you sum up all the subtasks. And this term, if you look at it, then you realize that what this is this is the maximum amount of time that any individual might have to spend absorbing context. Because this is the amount of time that you have to spend absorbing context of the task you're dependent on, right? So SU is the size of the prerequisite task times interdependency divided by expertise. I took out expertise earlier, right?
And his neighbors.
And is your prerequisite neighbors, yeah. And then this is the amount of time if you're assigned to the last delta sliver of your task, right? You basically have to spend SV times DV, EV time, picking up context, right? And we're maximizing this over all the nodes. So this is essentially saying that really the bottleneck is this max time on context, and that's encompassing all the other things. So I think for me, it's interesting to think about because it helps to think about, well, what other directions could we go in to continue increasing the complexity of tasks that we can support? In some sense, I'm interested in thinking about, well, what other designs or interactions can we use to decrease the context that people have or ease the transfer of context? And actually, if you think about micro-role hierarchies, it's essentially doing that. It's decreasing the time you need to pick up context, a process-related context, right? There's other results that you can use this model to prove. I haven't put it all in this presentation, but you can use the model to think about how do you recruit for complex crowd work. You can derive a feasibility boundary of like when is a set of workers assigned to nodes feasible. And basically what it turns out to be is for each node, if you look at the set of workers that are assigned to that node, remember they're carrying out tasks sequentially. Okay, so you can assign them non-sequentially to different subtasks, but for a given subtask, they're sequential. So if you look at the workers assigned to one subtask, and you order them from the person with the least amount of time, least amount of expertise weighted time, to the highest amount of expertise weighted time. It turns out that's the optimal. Okay, so you should start with the person with the least, and then go leave the most experienced person last. And the equation for the feasibility boundary is that you take the person with the most expertise weighted time and down, and you weight this by a geometric distribution with parameter d. Okay? And this is truncated because there's only a certain number of people, and normalized. Okay? So this is kind of just proportional to this. So if you kind of average people's expertise weighted times based on a geometric distribution, then if that value basically is greater than the amount of context, the maximum amount of context required for that node, then it will be feasible. And the closer it is to that limit, the more workers you'll need. So as you get close to that, then you'll need infinite number of workers. If you get farther from that, it will drop down. And it turns out that you can show that roughly the top, this number of workers approximates the capacity. So this is the number of nodes. This is the harmonic mean of the interdependency parameters for all the nodes. And this is natural log of epsilon. So, so if you have this number of workers, essentially they approximate the work capacity. So in other words, if you give me any number of workers, any assignment, I can say I'm just going to choose that number of workers from that set of workers you give me, and that will achieve a work capacity of 1 minus epsilon of the work capacity you initially had.
Because the rest of people are discounted.
Exactly. Yeah. You can also have theorems that kind of discuss the role of generalists versus specialists, and when should you recruit one or the other, when you have interdisciplinary work, or when you are adapting to different, when you need to recruit a set of workers that can adapt to different tasks with different interdependency structures. So you can kind of see that in a formal way. Yeah.
Results seems like they would readily generalize to distributed computation where you've got network time overhead instead of your T parameter.
Yeah. So explain more.
Well, so you've got a pool of workers.
Yeah.
And each one has a different capacity for work or a different speed at which they will work. Some architectures are more suited to different tasks.
I see.
And then rather than treating D as the amount of context you have to pick up learning to do a task, you can think of it as the overhead of communicating the task or transferring
interesting.
resources.
Yeah, that's very interesting. Yeah, very cool. Good observation. So we've also, so far what I've talked about, it's still not really touching on the original goal, which is the human capacity for taking an underdefined task and kind of discovering structure, delegating it, coordinating it out, right? That's kind of what I originally started motivating from. And we started to think about this. And the way to think about this is it's actually pretty straightforward to take these task graphs and to extend them to not just representing like the underlying true structure of this task graph, but to also represent the partial knowledge someone might have about a particular task. So maybe like some task has some true underlying task structure, but what an individual sees of the task or knows of the task is maybe completely structureless. So maybe they just see one node that encompasses the whole thing, or maybe they see a subset of nodes. So you can represent that by a partition of these subtasks. And then there's a way that you can model, if someone's working under partial knowledge, then basically what they're doing is they have to pick up all the context so they're assigned to a partition, right? So instead of being assigned to one subtask, they're assigned to a collection of subtasks because they can't distinguish between them, right? And when they're assigned to that collection, they first pick up the context for all of those tasks, right? Because they're working on it together. And once they pick up the context for all of those tasks, then they can start working. And the work they do because they can't distinguish between any of them, is just proportional on all the tasks. So they work on all the tasks proportionally, proportional to the remaining work that needs to be done. So you can define a model related to like working under partial knowledge, and you can also start thinking about like how do you model someone discovering structure? So probably if you have more expertise, you're more likely to discover, to kind of recognize a particular task, right? If I'm given something, I can be like, oh, like this mathematical side, I can kind of break it down. But the lawyer side of the legal side of this, I have no idea. I need to find someone who has expertise there. To me, it just looks like a big block, right, of work. So you can start modeling these things and start discussing like how do different protocols for distributing work compare across different people. This is stuff we're still working on and finalizing. So I'm going to wrap up by going back to this original question and kind of doing some more speculation on how do we navigate in a whitewater world. What I'd love to see is to redesign learning so it's more experiential, right? Where students are actually learning by working on real-world community projects. I think that we've started that experiment in Causeway, right? Mostly working with university students building nonprofit websites. I think it's possible not just at universities, but potentially kind of going down into K through 12, maybe with simpler type of work, but basically coupling learning with doing. And thinking about how do you also incorporate that into work, on-the-job learning, and how to enable people to transition from industry to industry. There's a lot of people who are discussing how we're going to deal with all the job destruction due to AI, and one of the ideas is universal basic income. It actually is becoming more discussed in the presidential election. And basically, everyone should get paid enough to survive. I think that maybe along with this idea, or some combination of it, there should be some form of like maybe universal basic learning. In the Great Depression, the government, what they would do is they would create these big government projects, like building bridges or infrastructure, right? It's like works progress administration, basically a way to give people a job while the economy, while the markets aren't doing well, right? That doesn't work so well when things are changing, right? Because if you give someone a job building a bridge, after they come back, they still haven't made the transition to the new types of work that are needed, in the changes in the economy. So I think it would be really interesting. I mean, I don't know anything about macroeconomics at this level. Again, this is speculation, dreaming. But what if it were possible to actually enable learners to contribute to real-world work? They obviously won't be as efficient as private sector employees, right? They can't compete with like a Google employee for building a website, but they can still complete work. So maybe, right, if we can figure it out. And so maybe you can imagine something like the Works Progress Administration, which was the stuff during the Great Depression, but focused around building different types of government projects using new technologies, right? So a way that people can learn as they're contributing to government projects so they can get paid through the government at a lower rate than the private sector. But it can also help people transition. I think it would be really interesting to think about whether volunteers could provide kind of operational capacity for nonprofits in a similar way that financial capital, provides operational capacity for corporations. If I think I resonate with this because when I was kind of exploring entrepreneurship and and thinking about the tension between monetization and mission, and exploring different types of models for social entrepreneurship and social enterprise, B corporations, all these different types of things. It's actually pretty hard for someone to keep those two things aligned, the mission and the monetization, because the operational resources you need to run even a social organization, a socially focused organization, is financial capital, right? So you still need money to run your organization, and it is hard to bring it together. Now, the problem with volunteers is that they don't build on each other in the same way that financial capital builds on each other, right? If like 1 million people donate $1, I have $1 million, yes, right? I'm gonna take over the world. But if 1 million volunteers give me a day of time, that kind of doesn't add. That's not equivalent to 1 million days, right? Because of exactly what we talked about, right? Interdependent work. So, if there was a way for volunteers to kind of, as they're learning, contribute or something like that, then you might be able to create some kind of like market dynamics that are more mission aligned, because you can also have like, just like in entrepreneurship, you just need to convince one crazy investor to believe in your idea, and then you can kind of get enough operational capacity to prove it out to the next set of investors, and then prove it out to the next set of investors, right? So maybe in this case, right, you just need to get the first set of crazy volunteers to believe in you, to prove out the idea enough to get the next set of crazy volunteers, right? And maybe that's more aligned because people who are volunteering will care more about the mission than the financial operations.
I'm surprised you haven't mentioned prisons, though.
What?
I'm surprised you have not mentioned prisons.
In what sense? Volunteer labor?
Not necessarily volunteer.
I was like, yeah.
Educational and labor opportunities.
Yeah. So that's interesting. Yeah, that's an interesting observation. I haven't really thought about that. I know that there are people who are working, I know several people who are working on different types of things in prison populations to provide educational, like startup, entrepreneurship type opportunities. And that's a great observation. Yeah. Yeah, we didn't get to really talk about polarization today. I think that's a really important and challenging issue. I think that two parts of that issue is that most of us don't know very much about the issues, different complex social issues, because they're complex, right? I don't know almost anything about most issues, and most of us, even though we'd like to think otherwise, are great at letting other people know our opinions, but not at listening to other people's opinions or incorporating them, right? So I wonder if you could actually get that doing by learning thing to work, right? Where people could early on be learning in the context of being engaged in their local schools, neighborhoods, cities, whatever, right? That might enable people to start learning about different issues and to start learning different civic skills, like how to disagree with each other in a productive way. And then we ended with talking about, can we think about how AI can play an augmenting role in all of these different pieces? Can we get to some vision of human-AI collaboration where you're blending design and models and data to think about how to support different types of complex human dynamics? So that's all I have. Initially, Yang had told me that you guys are working on projects, and if I wanted to, I could propose some projects. I just finished this talk literally right before, so I didn't get to think about that. But if anyone's interested in talking about some project, then email me, and I can try to articulate something for you.
Right. I think we definitely have some people interested in the education part. Like machine learning or AI for education, and also some people are interested in AI collaboration with people. So
Cool. Yay, thank you so much, Yang, for
thank you.
inviting me, and thank you all for listening.
It's a great talk. I mean, both parts are pretty impressive. It's like building the real system to demonstrate it's useful, and also this mathematical modeling part to give us insights. I couldn't imagine myself doing either of these things. That's why this guy is always busy. I've been asking this guy to give a lecture forever, and I finally had him. But thank you, David.
Thank you so much.
We have, so I'm going to be here for another 10 minutes. David, do you have?
Yeah, I can hang around.
Right,
Yeah.
so we're going to be here. If you have questions, feel free to ask. And otherwise, I'll see you on Thursday. Right, you need to sign up here. If you haven't signed up, please. I'll put it here.
Yay, thank you.
This is great. It's a mathematical part. When did you get that?
Just over the summer. I'm still writing the paper. And the main thing is, I didn't have PhD students. So I was like,
Did you do that yourself?
yeah, no,
That's really neat. Okay, I should ask people ask you questions.
Okay,
first.
yeah. Hey, okay, go.
I can talk about you about the project and graduated.
Oh yeah, okay.
So I needed a signature.
Sure.
I mean, as long as everyone's kind of on board.
Yeah, sorry, I was
I imagine we're fine.
I was traveling to Hustler. We already have internet access.
Okay, that's really good.
Okay.
I have a question.